Today's lesson is on side, 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 and hypotenuse-like congruence theorems. Side, side, side states, if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Hypotenuse-like theorem states, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. In our first example, we're going to write a proof to show that the triangles are congruent. We'll follow the same things that we've already learned for the other congruence test, which was the side angle side. So we'll create our truth statement and reason columns, and then we'll proceed the same way as before. Remember, either it's a congruent statement, you mark the drawing and move on, or you're going to write a congruent statement if it's not a congruent statement. So our first thing we're given is that PQ is congruent to RQ. This was already marked on the drawing, so we can move on to the next given. PS is congruent to RS. Again, this is already marked on the drawing, so we can move on to the next one. We're out of givens. Remember that if nothing else is marked on the drawing, we're allowed to either mark a common side or vertical angles. What we have on this picture is, you guessed it, a common side. QS is congruent to QS, and remember that's reflexive property. Anytime you have something congruent to itself, reflexive property of congruence. And now I have three parts marked on the picture. I have three things, 1, 2, 3 parts congruent written down. So now I can say my proof statement, triangle PQS is congruent to triangle RQS, and our new test of congruence, we've used a side, and a side are marked, so this one is side, side, side congruence. In our next example, just a different type of example, it says, explain why the bench with the diagonal support is stable, while the one without the support can collapse. We'll focus on these two triangles, again, to show that the two triangles are congruent. So notice on this one, if we make right angles at each of these corners, and then we have the right angles on this one, and then we also have the support beam right here, that's a common side, and that is congruent to itself. And then we assume that the vertical distance is the same. What we've created on this one is a different type of theorem that would support why the triangles are congruent. So we could say that the triangles are congruent, and this is by the HL theorem, which makes it much more stable of support. So in our next one, we're going to prove, given our segments are all congruent, we're going to prove that the triangles are congruent. So we're going to, again, write our two columns. So we have our statements and reasons. We'll start with our first given, WY is congruent to XZ, and that's given. I'll mark it on the drawing. So WY is congruent to XZ. Our second given is WZ is perpendicular to ZY. Remember, that's not a congruent statement. if WZ is perpendicular to ZY, we can also put the other perpendicular, because what that does is makes the right angles. So I'll put the other one on here with it. So I have a right angle here, and then the other one, XY is perpendicular to ZY, makes a perpendicular here. So angle WZY is congruent to angle XYZ, and those are right angles congruent. I have to have another part congruent yet to show the triangles are congruent. I have a common side, ZY, at the bottom. So I'll mark that on the picture. ZY is congruent to ZY, and that's reflexive property. And then finally I can say that my triangles are congruent. Triangle WYZ is congruent to triangle XZY. And in this one, oops, reason 5, not 6, we would use the, it's not side angle side, notice, because we have a right angle and we don't have the angle between the sides. We have the leg of the right triangle and the hypotenuse of a right triangle, so this would be hypotenuse leg theorem. In our next example, PQ is congruent to RS, and that's given. It's already marked on the picture. Angle Q and angle S are right angles. They're already marked as right angles on the picture, so all we need to do in the next statement is write that they're congruent, because this is not saying congruent. So we have angle Q is congruent to angle S, and that's right angles congruent. We're looking for another part. We have a common side again. PR is congruent to PR, and that is the reflexive property of congruence. Therefore, my triangle PQR is congruent to triangle RSP. And once again, we have a right triangle, and it's not side angle side, therefore it has to be hypotenuse leg. So if it's a right triangle and they are congruent, if it's not side angle side, more than likely it's hypotenuse leg. Our final example: two windows in a building are right triangles with WX congruent to XY. Prove the triangles are congruent. So we're given triangle WXZ and triangle YXZ are right triangles. That is given. From that, we know that angle WZX is congruent to angle YZX. Those are right angles. Since they're right triangles, they have to be right angles. Congruent. We also are given that WX is congruent to XY. That's given for a reason. That's already marked on the picture. We have a common side, ZX is congruent to ZX, and that is reflexive. Property of congruence. And then we have our triangles are congruent. By hypotenuse-like theorem. And that's all we have for today.